All right, we are right now on lesson 4. We're looking at problem number 4. The distance and height of Kurt Warner's pass. He was a quarterback, Hall of Fame quarterback, is given by the following information. Please go up here. Distance is going to be our X value, and height of the football is going to be our Y value. Now, grabbing your highlighter, we are going to highlight what we need to do. So we need to create a quadratic model based on this information. So you're grabbing the calculator. If you don't have one, you're going to go over and get it. And we're going to start by clearing our calculator after every single problem. Now, once I've cleared it, I'm going to follow the steps that are on the board behind me in blue. I'm going to go up to Stats, and I'm going to edit. Distance, 0, 10, 20, 30, and 40 will go into the L1 column. In L2 will be the corresponding values for height. I always suggest that you go back and you check your input values for both L1 and L2 to make sure they're correct. Now, after I've plugged in the values, I'm going to hit Stat, Calculate, and I need to go to Quadratic Model. So I'm going all the way down to number 5 and pressing Enter all the way through. It does not ask you to write this down. Instead, please go to Part B, and I want you to write Graph, and this is the key. Appropriate model means, do you understand the context of this problem, and are you viewing the model within the context of the problem? So once we have this, we're now going to copy and paste it using the directions that will remain on the board in red. So if we can go to Y equals, find the key that says VARS, go down to statistics, which is number 5. On the top, go across to EQ and press Enter. Okay, are you ready? Go to Windows. I want you to think of this right now. I'm going to grab a little piece of paper up here, or a little pen. So here's the quarterback, right? Here's the field. And if they throw a good pass, it's looking something like this, right? And if nobody catches it, it's looking something like that, correct? So when we're looking at the windows, we know this is the distance and this is the height of the football. That's our information as it applies to the context of this problem in this graph. So distance is always going to be greater than or equal to 0. Our height is always going to be greater than or equal to 0. So let's start by going, this is going to be kind of like a guess and check. Let's start by going 0 to 50. And then I'm going to do zoom fit, which is zoom 0. And I'm going to adjust it accordingly. So zoom fit, which is zoom 0. Now, I want to see all the way out to the point if nobody catches the ball when it actually hits the ground. Right now, I'm close, but I'm not there. So I'm going to go up to Windows, and you can kind of play around with this. I'm going to try like 75, right? Maybe you try 60. Let's see if we get it now. It's far enough. Can everybody see that? Let's now go up to Windows. Here's the deal. I want my Y minimum to be 0, because I want to show when it actually hits the ground. Yours may be slightly different, but now I'm going to take that. It shows that I understand the context of the problem, and I'm going to put these values in. So it goes from 0 to 75, and it goes from 0 to 41.96. I'm also going to write this is distance of the football, and this is the height of the football. And then I'll go up to graph, and I'm literally going to just do exactly what I see. Looks like that. Coming back now, we are going to go on to part C. We have 3 more parts here. I want you to take that highlighter, and we're going to highlight how high. Then I go back and I'm like, high. Okay, they're talking about height. They want to know a Y value, so please put Y equals. We can see that the height of the football is measured in feet, and we do need to make sure that we are correctly labeling the units. So how high did the pass go? This is what I want to be able to identify. I want to know this maximum value. How do I calculate it? We're going to go second, calculate maximum. And there's a couple different ways that I taught you how to do this. This is probably the slower way. You start at the very top. You go somewhere to the left, press enter, come back up. You go somewhere to the right of the highest point, and then you guess the highest point. Now here's where students struggle. Students struggle by identifying which number do I write down, Ms. Bradley? Do I write down an order of pair? Do I put the X? Do I put the Y? That's why we highlighted this question. How high? How high is your height or your y value? I want to know the height right here. Height is the y. The correct answer is, let's round right now to the nearest hundredth, 41.96. 41.96. Let's look at part D and part E, which had me rereading it last hour several times. Let's start with part D. The pass fell incomplete. That means nobody caught it. Please underline how far. How far? How far is a distance? I want to know what is the x value. So if nobody ever catches it, remember this is the pathway of the ball as described by the distance on the ground and the height above the ground. So if nobody ever catches the ball, I want to know when it hits the ground, how far did it go? When it hits the ground is the x-intercept, also known as the 0. Let's calculate it. Second, calculate 0. Now, there's a couple different ways we can do this. I'm going to do it what I call is like kind of the shortcut. I want to choose one number to the left, anywhere to the left here, so let's do like 25, and there's going to be that temporary line. Now, anywhere to the right. Now, if I remember right, it went all the way out to 75, so I'm going to choose 70. And as long as my x-intercept, or 0, is in between these temporary lines, when I press enter, I get an answer. In the last few days, several students are confused. They're like, I see an E. Remember, this is scientific notation, but really this is approximately 0. So this is 55.37, 0. But it does not ask for an ordered pair. It asks how far did it go? Well, that's the distance in yards. So that's the x value. 55.37, 55.37 yards. Make sure that we have correctly labeled it. And if you're like me, I read part E, and it says the exact same thing again. It says, how far does the pass go before hitting the ground? Well, that's exactly what I just did. Why was I confused? Because it wants the same distance along the ground, but instead of us giving the answer in terms of yards, it wants it in terms of feet. On the board, you can see that 1 yard is equal to 3 feet. So every single one of these yards is 3 feet, plus we have this remainder. Please grab your calculator. I'm taking 55.37, and I'm taking it times 3. So the correct answer for part E would be 166.11 feet. These are equivalent distances along the ground in measuring how far did the ball go before it hits the ground if nobody catches it. One is measured in yards, and one is equivalent but within feet. How far? Please go ahead and underline or highlight that. How far did the pass go? If Larry Fitzgerald, which is a Hall of Fame wide receiver for the Cardinals, or former wide receiver for the Cardinals, he jumps up and catches the ball. So if you're not familiar with football, you're thinking, what's going on here? So we're going to actually do a little graph of this. Please come up here, and I want you to make a little dotted line on your graph, and we're going to say this is 10 feet above the ground, so 10 feet. So Kurt Warner, here he is, and he has the football. He goes and he throws the football up, and then as it's coming down, Larry Fitzgerald is running out a route here, and Larry jumps up and he catches the ball when it's 10 feet above the ground. So the ball is coming back down, and he catches it right here. Go ahead and draw that picture, please. And how far represents the distance, or the horizontal distance, and we can see our distance is measured in yards. So what we're going to do is we're going to go up here to y equals, we're not going to erase anything, we're going to go to y sub 2, and we're going to type in 10, and then we're going to graph it. So the play begins, the ball is hiked, Larry is going to go out, he's running a route, he's ready to catch it, he jumps up, Kurt has thrown the ball, and he catches it right here. Now when we find this intersection point, we can do that by going second, calculate, please do the same with me, second, calculate, intersect. Remember to find this, we're going to get close to the intersection point, but not on it. Press enter, it'll jump to the next line called the curve. Press enter again, and then go over the top of where you believe they intersect. So how do I know whether to write down the x value or the y value? Well, that's why we highlighted this. How far represents the horizontal distance. So this is 51.71 yards. That's how far horizontally the ball went before Larry jumped up and caught it as the ball was coming back down.